action.
Hello Science 8, we're going to do Lab Investigation 2.4 now. So I'm going to read through that with you, but first let's look at the materials that we have. We have 5 of the alligator clips, the connecting wires. We have a battery, a D-cell battery that's 1.5 volts in the battery holder. We have the bulb, the light bulb, and the light bulb holder. We have a switch, and then we have our voltmeter. So if you want to read along with lesson Lab Investigation 2.4 that's on Schoology, you can, or you probably should, so you can answer the questions. But it says, in Investigation 2.2, you designed an experiment to answer a question about current. In this investigation, you will design an experiment to answer questions about voltage and the brightness of a light bulb. So in 2.2, we looked at the difference between series and parallel circuits, and we looked at increasing the number of batteries to see what that did to current. And remember, we measured that with an ammeter. Today we're going to be measuring voltage, and we measure voltage with a voltmeter. So instead of an ammeter today, we have a voltmeter. So we will assemble the system as shown in figure 2.8. So you have this figure, and then it's okay, it's all right. And so you can look at this figure on your sheet, and you also have the schematic. So in this schematic, you have the battery, the switch, and then you have, we were calling these loops, but you have another loop going to the voltmeter, coming off of the light bulb, and then going back to the battery. So I'm going to connect these now. So I've got the battery, and I've got the positive end. So I'm going to go ahead and set this up where the positive end of the battery is going to be closer to the positive end of the voltmeter. So I want to go battery to the switch, and then from the switch I want to go to the light bulb. And remember, we always have our switch open when we're connecting everything. And so then we go to the light bulb. From the light bulb we go to the voltmeter. So we're going to go to the positive, and then from the voltmeter we go back to the light bulb to create that loop. So instead of now going to the battery, we're going, find these look a little better. We're going to go back to the light bulb. From the negative, we go back to the light bulb. So what you need to have is one continuous loop from the positive, so positive to positive. And now that we've got, I think it's going to be easier to do it this way. So positive is going all the way here, and you need to keep the alignment with the positive on the bulb going to the positive of the voltmeter. Now we're going from the negative end of the voltmeter to the other side of the bulb holder, and then from that same side we want to go back to the negative end of the battery. So now we have everything set up like what's seen in the schematic, in the diagram. So it says, look at the materials provided, write a question about voltage and the brightness of a light bulb that you could answer using these materials. So you think of that question right now. So you're looking at voltage and the brightness of the light bulb. What do you think is going to happen to the voltage of, or the brightness of the light bulb compared to the voltage that you're seeing coming from the battery. Then number 2 says to plan an investigation that will answer the question that you wrote down. So going towards your question, what are you going to do? What are the steps you're going to take to try to answer that question? And then how will you gather data for your investigation? So what are you going to need to measure? And then think about the data table that you would use. Number 4, write a prediction for what will happen. So what will happen to the circuit system when you carry out your plan. So if you're thinking about voltage, and the higher the voltage, the brighter the light, make a prediction for that if that's your prediction. And then what is the dependent variable in your plan? So the dependent variable is the variable that you, and you're the experiment, will change. And then what is or are your dependent variables? And the dependent variables are the variables that you measure when the independent variable is changed. So which variable are you measuring? So answer those questions. And then what is or are your dependent variables? So this is the variable that you measure when it's changed. I think I said that twice, so sorry about that. But which variable should you keep constant or controlled? Remember, with investigation 2.2, we kept the alligator clips constant, we kept the type of battery constant. In this one, we also need to think about the bulb and keeping it constant as we change throughout the investigations. So number 8 says use the table below to create data tables. So I went ahead and filled this out for you for what I'm planning to test. If you would like to test something different, you can make your table, and then on the very last sheet on Schoology, I left this blank so you could put your data tables if you wanted to create a different data table. But if you want to follow along with me, I'm going to be filling out this data table with you. So for the brightness of the light bulb on this column, so on this last column here, it says for the brightness of the light bulb, choose between the words dim, bright, slightly brighter, or about the same as 2 batteries. So that's what you're going to be putting right here. You may use my information, or you can create your own data tables in Google Doc and paste them at the end of the document. So that's what I showed you just a second ago. So what I'm going to test is the number of batteries and then the voltage across the light bulb. So I'm going to figure out the voltage on the voltmeter as I increase the number of batteries, and then I'm going to look at the brightness of the light bulb and compare that. I'm going to do that in series circuit and also in parallel circuit. So let me get another battery out here. So again, I forgot the other battery and battery holder, so we're just going to do 2 batteries tonight. So with 1 battery, my voltage as I close the circuit, my battery is reading, what does that look like to you?
1.4.
1.4. So the voltage for 1 battery, show this. So the voltage across 1 battery is 1.4, and then let's look at the brightness of the light bulb. So I'm going to dim the lights, and you can see it with the lights out. So that, I would say, looking at that light bulb, I would say that 1 is sort of dim. So I'm going to say that this, I'm going to choose dim to write in the brightness. And now I'm going to do 2 bulbs in a series. So let me get the same battery is what I have. So I'm changing out so it's the same. And open the switch so I don't electrocute myself, and then line up the positive to the negative with the batteries. Clip those in. And so now I'm just doing the series. So clip that one, and I'll close the circuit. So is it about 2.8?
Mm-hmm.
Okay.
7, right?
All right, so we'll say 2.8, and if you have done less than 2.3 already, you know that as we add batteries, if whatever number of batteries we have, we say the voltage of one battery times the number of batteries to get the voltage of that number of batteries. So we're doubling the voltage as we add more batteries. So I'll turn off the lights and we can see how much brighter. So you can see how bright that light is compared to just one battery. So I would say that this is bright. Okay, and like I said, I don't have the third battery, so we'll keep that blank for right now. I'll try to do that when I have the materials at school. I'll try to video that again. So now I'm going to open my switch, and remember with just one battery, so I'm going to fill out the parallel circuit data table now. So just with one battery, my voltage was 1.4 and the brightness of the light was dim. Okay, so now I'm going to put the batteries in parallel. So remember, that's when they're stacked on top of each other. Okay, so that's when the batteries are stacked on top of each other like this, and then I need to hook up the positives again, and then the negative. And so now I'm going to close the switch. And so just like with Lab Investigation 2.3, we know that when batteries are in parallel, it doesn't change the voltage across. So does it look like 1.4? So yes, it's still 1.4. Okay, and I'll turn out the light. So that's what it is with two batteries in parallel. I'm gonna take off the first battery, and you can see that the dimness didn't change. So you can see now that I've got the one battery there. So I'll put it back on with the lights on. It'll work quickly. You can see that the brightness doesn't change at all. So on here, I'm gonna put that it's still dim. Okay, so let's move on to the next. So I'm going to open my switch. Okay, so it says look at the data tables and do they show a pattern? So if you're looking at the data tables, you can see that as you add another battery, the voltage is doubling. So you're adding 1.4 each time you add a battery. And the brightness of the light in a series, it went from dim to bright. But in the parallel, the voltage isn't changing, so the brightness isn't changing either. So answer number 9 based on the data. So whether or not it creates a pattern, does the data show a pattern? And then tomorrow I'll do another video like I did with 2.3 to help you graph your data after I do the third battery. And then you need to answer the conclusion questions 1 through 5 and then turn it in after you do your graphing table. But I hope you've enjoyed this. I hope you're all doing well, and I'll talk to you again soon. Bye.